back to episode 3 of season 2 of the XDI Experience Live Show. Thank you so much for joining us. I know the world is getting busier and busier out there, so really do appreciate you stepping in out of your day and taking around 45 minutes today to be with us. Today, we are talking about a hugely experienced sector, a massively experienced guest, and a big subject, and that's model-based systems engineering, MBSE, that word. Let's do it. Now, I, for one, have been through various complex designs and have experienced firsthand the challenges of keeping everyone on the same page. Yes, we have design team meetings, we have real-time collaborative platforms, but then even when we're in the same country, talking the same language, never mind engineers that are dispersed all over the world, we manage to misunderstand design intent and many of the details as we pass them along the line. Welcome to the model-based systems engineering world, and welcome to one of the foremost experts in MBSE. 8 years dedicated now to MBSE, cross-industry, Alexander Jackson. He's been working with NASA for some time now on advanced air mobility and Army hypersonics. Welcome to Alex Jackson. Ready, set, let's go.
What kind of plane is that?
Is that the new supersonic airplane everyone has been talking about?
That looks so complex. How did they actually design it, and in such a short amount of time?
There he is, Alec. Hey, good morning. How are you?
Hey, how you doing?
Doing real good. You?
I'm doing pretty good. I can't complain.
Yeah, family good. Everybody hunkered down, starting to get out into the big wide world.
That's right. Got my second COVID vaccine on Saturday. Was KO'd yesterday and feeling alive today, so we're good to go.
Oh, well done. No reaction. Another couple of weeks to go before you're bulletproof.
That's right. I think
Good,
so.
good. All right, today, Alec, we're doing 3 main things. We're going to start off with a quick fire round, 3 minutes, full blast, 6, 7, 8, 9 questions for you to kind of keep you on your toes. At the end of that, I'm going to reach out to the audience, see if we've got anybody who agrees, disagrees, has any questions related to that. Then we're going to go into the main event where we're going to talk MBSE. What is that complex, enormous world all about? Again, break off, see if we've got some audience questions coming in, and then wrap it all up with what's going on with you today and for the future in your world of MBSE. So if you're good with that and you're ready.
Let's go.
Okay, let's do the quick fire round. Let's start that clock. There it is. So if you're on your toes, we'll get started. Hopefully, pretty quickly. There we go. All right. Why did you get into MBSE?
Yeah, so I started my career in AI on embedded systems, and a lot of the bugs that we were finding were actually inconsistencies on the logical side of things, from the hardware to the software mapping. And so MBSE enabled us to truly understand the overall system in a way that we weren't able to do prior to that. So it helped us eliminate errors in the significant amount, something like 80%.
Okay. What do you love most about MBSE?
Yeah, so my favorite part about it is if you can imagine or if you can conceptualize anything as a system, the same procedures, the same processes actually propagate across and you can apply it in the same way with the same ROI.
Okay. And what do you least like about it?
It's got a very steep learning curve. I'll tell you that realistically what it reveals is if you don't know how to do proper systems engineering. And so if you think you're just going to pick up a modeling tool and become a good systems engineer, it's not the case. So MBSE is a challenge in itself.
Got it. Got it. Okay. What advice would you give to a new engineer who wants to get into this big world?
Yeah, so my biggest advice is get a mentor. So there are things, so in my opinion, there's two classifications of these MBSEs. You have theoretical and functional. The functional ones are the ones that you're wanting on the projects actually building the things. And those need to have someone to help direct them that have been there before in order to not waste time and get something valuable out.
Okay. Who's your mentor and why?
Yeah, so my biggest goal always has been to never stop learning. And so anyone that can teach me anything has been really my mentors. A lot of the ones in the MBSE field's been Sandy Friedenthal, who's the author of A Practical Guide to SysML, Sally Spivalkis and Barry Papke from Dassault, my father-in-law, Gary Duncanson, and several others.
Who was your father-in-law?
He was the ex-CEO of No Magic.
I thought so. Okay, there we go. Good. What is SysML?
Yeah, so SysML is a systems modeling language, and it's one of the only standardized languages registered with the OMG for doing MBSE.
Got it. And what are the features to be successful with the MBSE tool and why?
Yeah, so for me, it's reuse, modularity, and traceability. Reuse because you don't want to spend time and money rebuilding the same thing over and over again. Modularity because you don't want it all to go in one giant model that you can never find anything in. And traceability so you actually understand the impacts of things downstream.
Well under the wire. Well done. Okay, quick one from me. We asked what is SysML. What is UML as a comparison?
Yeah, so UML is the unified modeling language. And now that SysML is there, SysML is optimized for systems engineering. UML really has become the software architecture, software engineering tool.
Got it. Got it. Okay. All right. Quick check. No questions coming in yet. Early days. That's fine. I think they're waiting for the main event. Talking of which, thanks for that. Let's go to the main event. Let's talk MBSE. There we are. So, Alec, MBSE, I scratched my head why this is not already, but I'm sure will become the kind of whole de facto engineering approach to not just complex products, but arguably even the simpler ones as well. It's a huge world. Tell us, what is MBSE and who's using it?
Yeah, of course. So MBSE, like you mentioned before, stands for Model-Based Systems Engineering, which realistically is the use of modeling to perform the standard systems engineering tasks like requirements, system architecture definition, system function definition, and even verification that the architecture will meet those requirements using lightweight mathematics behind the scenes.
Got it.
So you asked who's using it. Realistically, so the defense space is mandating it, so it's really driven heavily on that defense sector. But that said, a lot of the values have been noticed from the commercial sector, and it's propagating across many different industries.
Yep. How long has it been around?
So arguably, and this is so when I was at NASA at JPL, they made this claim, and they've got pictures to prove it, that they were doing model-based systems engineering back in the 60s with their landers and all the other stuff, because they had their picture, boxes and lines diagrams. Can't argue with that, right? However, this formalized, standardized process ties back into the 90s with UML, and then SysML is released in, I believe, 2005. So it's relatively infant.
Got it. I mean, 15, 16 years in full force. Why is it taking this long to really grab hold of various industry verticals? I get the space, I get the defense, get the aviation. Why is it not really kind of being propagated across a lot more verticals so far? Yeah,
so time back to my Alabama days, there's a statement of, if it ain't broke, don't fix it, right? And so
the reason I came out of Alabama.
I don't know. I came from the South, and we're all good about claiming it for each state that we've been in. So
okay, good for you.
But that said, so the reason I mentioned that is back before the 2000s, right? Before this new technological revolution that we're a part of, right? The digital age, things weren't as complex as they are today, right? Even in the 90s, you didn't have all this AI and ML and security verifications and safety and all this other stuff you're having to track. Now that it's become so complex on the just the basic systems, we're having a very, very tough time trying to track that in the requirements, or I'm sorry, in the standard requirements documents and spreadsheets, etc., that were acceptable until around the 90s. So now you're having to move into that MBSE space just to manage the data.
Yeah, get it. Okay, and also collaboration around the world is more prevalent, etc., as well.
Exactly.
Okay, so what are the challenges with MBSE? What are the common mistakes that you've been seeing?
Yeah, so the first one is, like I mentioned in the quick fire round, really that steep learning curve sometimes dissuades folks because you're going to struggle at the beginning, right? And it's not an easy button for systems engineering. So with that, realistically, that's why it's so vital to have that mentor, because if you're going to go and try to do this on your own, odds are, and it's a proven use case from many different groups, odds are the first time you do it, you're going to fail at it. It's a lot of data management. So having that mentor to kind of help you with your training wheels and look over your shoulder does shorten that curve to success. But the question is, where do you find them, right?
Yeah, agreed. I mean, what else, other than a mentor, what else can you do to kind of speed up MBSE?
Yeah, so the other way to speed it up, right, is go ahead, first and foremost, training, right? So obviously go and get training, get formalized training, learn a tool, actually apply it. It's great to know the theoretics behind it, but you truly don't understand something till you've actually applied it in a given project, right? So go and get your hands dirty. The other way to speed it up realistically is have a common process or process guide for your groups, right? Have a common template they follow. So that way they have those training wheels, but don't restrict them to that template. When they're ready to advance, let them explore, but have those materials necessary to enable their success.
Yeah, nice. Okay, so what other challenges, what other mistakes you see?
Yeah, so another big one is inconsistent methodology. So this is the fun one, right? So think back, Tesla versus Edison, or object-oriented programming versus functional programming, right? Arguably, there's no right answer. They're both correct. However, they're incompatible, right? They're not the same way of doing these things. And so what you have to realize is just because you have this language is like picking up the dictionary. It doesn't tell you how to structure it. And depending on how you structure the language depends on how it fits into other models, right? And so because of those inconsistencies in the methodology, realistically, that's why another reason for the mentor, you take a step back and analyze your project for what am I trying to get out of this model and what's the best approach to get that success in the most optimal fashion.
Yeah. Wow. When do you think you picked up that kind of methodology? 1 year, 2 year, 5 years? I mean, I know you keep learning, but how quickly?
I felt like I was beat into me with a stick by Mr. Barry Papke when I worked for him at No Magic. No, it was a lot of, I don't even know if I have the answer today, right? No, I'm just playing. It takes a while. I'll tell you, I've read, it was about 3 years ago, I could claim to have read all the MBSE books on the market and had been really subject, which is quite valuable to me. I was being a part of No Magic and Dassault, I was a part of this MBSE community, and I got to see at our yearly conferences all these different ways to actually go about doing this stuff. Okay. And so from that exposure, I was able to pick up a whole lot So I can't give you a time frame because I don't know how to quantify since it was so rapid, if you will.
Got it. I mean, to me, it feels like your mindset needs to be, when you're designing something, you've not just got to think about how does this connect with the bigger picture, but how could this be scalable into other products long term as well. So you've got to really kind of not just think about today, which you've got to, but think about that scalability as well. Is that fair to assume?
Absolutely, yeah, and that's kind of so the methodology that I published this year and that I've been presenting over a year and a half now on Model of Models. That's literally what the goal is to have that reproducible process. The goal being with Model of Models for maximum reuse. So
Got it.
now you have reuse of these products and whatever else you need from that point forward.
Yeah. But how do you take on this elephant? What's your approach to that?
So your approach to taking on the elephant of just standard modeling, or do you want to
Yeah,
refine
no,
a little?
you're taking on these big products. I mean, how do you break that down
Yeah.
into bite-sized chunks? What are the mistakes? What are the solutions?
Yeah, no, I got you. So modeling the universe, which is the term that we often use if you're going to go and try to just model everything, is always a bad move, okay? Unless you're NASA, you shouldn't be modeling the universe. Be careful with that, all right? They might actually need to model the universe, but if you're not NASA, odds are you probably don't need to know what the gravitational pull of like Mars is, right? That probably doesn't
Yeah,
impact you. So the big thing is realistically scoping, right? If any PM understands this, it's the same kind of concepts. What do I care about? What am I trying to accomplish? What do I currently have? And what do I need? Right. So
right.
breaking it down based off of those categories. And then once you can start to figure out where the gaps are, well, first of all, if you already have it, just get it into the model. There's not a whole lot of exploration going on.
Yep.
After that, now you know where you need to prioritize not just the modeling, but the analysis to actually create those features and ensure that that system works like it's supposed to.
Got it. Got it. So a bit of a waterfall kind of aspect to it, understanding, and then down into more of a broken down agile approach. Is that fair to say?
Absolutely. Yeah, I'm a big fan of we call it the concept model. So for the concept model phase, when you're defining what the stakeholders are wanting and what the initial use cases are, etc., that should be waterfall because realistically you need to keep that big picture in mind, right? Then you go into, as you start to go down the line, when you're building out subsystems and things like that, a iterative approach, bringing in those domain experts into the fray as you're making those decisions. And that typically, and it's not to say that you can't push data back, right? I can always add another use case later because I need to, but you can't really just start to create something if you don't even know what your concept is. You know what I'm saying? So you do need that initial kind of waterfall, then iterate, and there is a feedback loop, but it's not as substantial as in the iterative cycles.
Got it. Got it. So I think you probably defined it, that kind of high level steps that you would go through. I mean, could you summarize what you do on that?
Yeah, so, and this is one of those things. So realistically, you almost need to model the way you're going to model to do it correctly. And the reason I say that is it depends on what you have, right? So typically, let's say that I've got a set of requirements, right? So I've got what the customer wants, and I've got, maybe it's a modification, which is very standard, right? I want to add a new feature to an existing system that's already doing its good job. Well, now I have a structure and I have requirements. So I'll start with the requirements. I'll start with capturing the structure, and then I'll start to do the behavioral modeling, as well as understanding, do I have components that can already meet these functions, or do I need to add new components to that structure for a new variant to accomplish those, right? Contrast that though with like what I'm doing with urban air mobility. So for NASA, for that, we don't have a system yet. There's no such UAM vehicle that's actually out there. The closest thing we have is a helicopter. And so what we have is we also don't have requirements because the FARs don't necessarily apply across the board yet. So what we're doing is we're analyzing what are those functions that we believe need to be exhibited for this to be successful, meshing that with systems, and then researching, is that capable, and then how successful, how much probability of success do you have, and then finally spitting a requirement based off of that research.
Yeah. Yeah. Sounds 24/7.
You got to be agile, man. That's the big thing.
Up here anyway. Yeah, for sure. Yeah.
Coffee is also helpful.
Yeah, you bet. Incredible. Okay, so let's look at the kind of future of MBSE. Short, medium, long term. Short term being over the next 2 to 3 years, medium term 3 to 6, and crystal ball beyond. What do you see as the future of MBSE short term?
Well, so first and foremost, I see MBSE being the future of systems engineering, just like modeling's already the future or the current of electrical engineering and mechanical engineering, etc. So modeling is going to be there. It's not going away. We're not going to go back to, instead of typing on Word, to going and writing with our quill pens or taking a chisel and smacking a rock, right? You're advancing.
Yeah.
So we're here now. We're modeling. The short term is getting mandated by the government for a lot of the defense side of things. And because of that, what's going to happen is groups that were successful with what we call traditional systems engineering, which is those document based, are going to have to dip their toes into MBSE because they're now required to do so.
Yeah.
And once those benefits start to get realized, it's going to propagate. So it's going to be, the short term's a lot of dipping your toe in and figuring out how to just survive, if you will, right? Survival MBSE.
Yeah. Yeah, because you're going to be connected with the ecosystem. So it's as you say, it's going to propagate throughout. Got it. So what about medium term over the next 3 to 6 years?
Yeah, so medium term is going to be more of, so now people have dipped their toes in, right? So now they know, hey, this MBSE thing actually is useful, whatever, right? So maybe, like college classes, maybe you've failed out the ones that couldn't survive it from the get-go. I don't know, I'm just playing. But anyways, so now that they've realized that that it actually works, what's going to end up happening is the adoption is going to not only be as heavily focused in the automotive and transportation and defense like it is now, but also propagate into different uses. Like there's some exploration in biotech. I think that's going to be big. Financial, there's a little bit. I think that's going to grow. And the reason is once you start to take this systematic approach to things, you can really start to make optimizations regardless of what that system is.
Got it. Got it. So what's the future? What's the long-term crystal ball of
yeah, so the future of it realistically, so the middle term, we're going to start to really optimize it and flesh out a bunch of common processes to make sure that this is consistent and whatever. Once you start to have these common processes, now it's prime for automation, right? So we can start to automate, especially if you're doing things like I coach, where you're storing that data in a reusable fashion. Now we can start to bring in tools like artificial intelligence to help us not only optimize our systems, but perhaps with things like genetic algorithms, go and grow me the system, right? So go and grow me the top aircraft that does blah, right? Or that's the wife in the background.
But I mean, yeah, AI automation had to come into it. I agree. Yeah.
Yeah, so that is going to be the future. AI is not going anywhere either. It's just going to get better and better. Yeah. And the big thing is guided artificial intelligence, right? I've had people ask me before, why can't I just write an AI to pull out my requirements into a model? And my response was, well, first and foremost, do you like being employed? And second of all, so assuming you like having a job, second question for you is, have you seen how bad requirements typically are written? Your system's going to come out looking like Igor, pulling it out automatically, right?
Beautiful. Love it. Love it. Good, man. Thank you for that. We've got questions coming in thick and fast. I'm going to be selfish just before I go there really quickly. Sorry, I'm going to ask 2 questions myself, which are very selfish of me, I know, but ETO environments.
Right.
Creating, you've got your sales guy out there. Yeah, we can give you anything you want, any place you like at any time, no problem at all. And there's abject chaos when it reaches the engineers. Can this help create product structures that kind of is still ETO, but contains it, gets it organized? Can it help with that whole ETO environment?
Yes, I believe so. So, I mean, realistically, what I had done in my past, so when I was at JPL, I was 50-50 with Europa Clipper and Team X. And what Team X does is they take like 50 of the top engineers at the center and stick them in a room and lock them in, if you will, for a finite period of time, let's say 2 hours, where a company, let's just assume that someone that wants to drill asteroids comes in and says, hey, we want to know how much it's going to cost us and where we need to invest our money to be able to do this, right? what they did was they already began streamlining these kind of concepts. So they have this backlog of the missions that NASA has done, as well as what are their standard components and all this other stuff. And they're able to essentially piece together and find the gaps in this mission that would not be able to be solved today, and tell them where the research has prioritized and a rough estimate of how much the cost would be.
Okay.
So I believe so.
Yeah. Yeah,
But
makes sense.
yeah.
Yeah. Okay, got it. Last one from me. Can you connect MBSE straight into ERP for procurement? Or do we still need to bring the PLM, variant management into the MBOM, et cetera, et cetera?
So I'm a big believer in everything has its place. So you said, can we? I'm sure you can, but should you?
Yeah.
I think that PLM provides a lot of value in that. For instance, in the MBSE, I don't care what color your car is. I don't care what rims you have. I don't care what tires you have, right? It doesn't faze me, right? In that PLM space, it absolutely makes a difference, right? And that ties back to your original question, because if you can tie those together where the MBSE architecture is evaluating those variants against those requirements, then yes, it connects right into ERP through the PLM. But also, if your salespeople are just, out there blowing smoke, at least they're constrained on what they're able to suggest to people as well.
Yeah. So I still need that product sales configurator, yada, yada, yada. Okay, good,
Exactly.
good. Okay, let's go to the audience, as we should have done maybe 5 minutes ago. But here we go. First one, do you connect the model to the EBOM, MBOM? I think you probably touched on it, but one last one.
So my answer is, again, you can. Maybe it depends also how complex your system is, right? So if you're doing a very simple system, then there's nothing wrong with just pushing out an EBOM or an MBOM from the model. However, if you have something like a car or an aircraft or whatever, you do need a PLM for variant management and that kind of stuff, and they will push out those artifacts.
Right. Good. Thank you for that, Umi. Next one from Hariram Shanmuganathan. Some MBSE tools do not implement SysML to full force. Will SysML become the de facto modeling standard for MBSE?
I can't say yes. Realistically, you always have to have variants, right? Back to my Edison versus Tesla moments. SysML is really good for if you need to interconnect data from across different industries or different providers. So if I need to take, in my defense space, many different providers and have all their data come together, SysML gives me that framework to do so. However, tools like Genesis are really nice for those individuals that just need to build something in their own labs, but aren't going to have to share that data outside. So I can't say it's going to be the de facto standard. I do like it as the standard. I think it's well written. I just don't want to over prescribe. Okay, good, great. Hopefully it answers your question, Haran. If you got one, fire it in. If you got another question. Next question from Iman. Is there a rapid start model to build model of models? So I do. I actually have a prototype that I send out, and you can connect with me on LinkedIn. It's Alec Jackson. MTSI. That's why I wore the shirt, so it's easy to find me. But anyway, so if you connect with me there, ask me for it, and I can send you. It's of an automobile, and it gets you started on the model of models. So that's Alec, AlecJackson at MTSI-VA.com. But here, the dude on LinkedIn, just look me up, Alec Jackson. Boom. Okay, got it. Thank you. All right, let's go to the next question. From back in Hariram. No, we got that. Question. Had that one. Yeah. Next from Umi. Have you ever calculated the ROI on the introduction of MBSE? So what I've done recently is I actually came up with a standard formula for, I can't say a standard ROI for MBSE because there's different ways to do it, right? But for model of models, what I was able to do is come up with a formula that tells you how valuable it is to you. And so for this, it's quite simple, literally, and I can paste this or whatever into chat, it's fine. But it's essentially the amount of time that it took to create a component multiplied by the amount of time that you use that component plus everything else in the library with the same equation. So the more stuff you're sticking into architectural libraries and you're reusing, you're saving that time each and every time. There's your ROI. It's exponential.
Very good. So a bit of a time and motion study applied to it as well. Good, good. Next question from a LinkedIn anonymous user. Do you have any recommendations for MBSE implementation readiness level measurement tool, methodology, and language to identify maturity of organization / project stakeholders?
So in my opinion, and if I missed this one, correct me, but I think this is what you're asking. There is a really, really good MBSE maturity matrix that Incozy published. I actually know the guy that did it. His name is Mr. Hale. Can't remember the first name. Out of Huntsville, Alabama. He used to be their Incozy president. And so he published this MBSE maturity matrix, and it answers exactly what you're looking for. So instead of reinventing the wheel, go look that up. It's through Incozy. It's free if you're an Incozy member, and it will help you out.
From Mr. Hale.
Yep.
Great. Okay, good. Hopefully LinkedIn user that answers your question. Come back if not. Next question. From Iman again, does this approach the essential part of developing the product digital twin?
So for me, let's define digital twin real quick. Okay, so different definitions depending who you're asking. To me, a digital twin is like the tail number, right? It's the physics-based model of that thing that, you know, if you have a bullet hole in your wing, that model has it too, right? It's literally the digital representation of your system. So I'm not going to claim that the MBSE is the digital twin, but I am going to claim that the MBSE should produce the digital twin. So you should define the requirements in the architecture and then essentially spawn off the digital twin as a variant from that architecture.
Nice answer. Very good. Next question. From anonymous LinkedIn user, what is your comment about future of MBSE and integrating the digital twin tread in life cycle concept?
Yeah, so again, I'm a big fan of everything. So digital integration, digital engineering, digital thread, whatever term you want to use, the integration, the synchronization of data across many different engineering tools. And so because of this, realistically, so remember my PLM comment, right? PLM hooked into MBSE enables me to run variants against requirements in architecture to actually verify that they're going to be successful. Now add that digital twin piece and actually create a CAD model that does the same thing, right? You have that traceability back. And if you try to modify something in the CAD and it breaks a requirement, and this isn't here today, by the way, this is vision. So someone go build this and you'll make a lot of money. But at the end of the day, realistically, my vision is, and this isn't coming from me, it's from Phil Zimmerman and all the DE folks, but you'll be able to, as you make that modification on the CAD model and you break a requirement, automatically see what's broken and then understand what the impact is. So do I need to change the requirement? Do I need to just not stick that there? You know what I'm saying?
Yep, got it. Beautiful. Nice. Next one. Next question. Coming in from Rabindra Sar. Thanks, Rabindra. Can you throw some light on using MBSE in process and facility planning?
Yeah, so I like it. Actually, I hadn't thought of this until about two months ago, and someone brought me this as a challenge. So treat it like a system. Treat it like a system. Get your requirements out. So what are you trying to get, right? And guess what? You're going to have OSHA requirements. You're going to have requirements for safety as well. You're going to have security requirements. You're going to have optimization requirements, etc. The one thing to realize is MBSE can't tell you about spacing. There is no such thing as physics in MBSE. So it helps you plan what kind of equipment you need to achieve what kind of things you're trying to build and how fast you need to operate and potentially how many operators you need to make this optimal. And then what you'll have to do is figure out with some other tool how to space those for the optimization, but it still helps you track that planning phase.
Yeah, yeah, great. Hopefully that answers your question, Rabindra. Keep them coming. Next question. From Kapil Patil, what would be the best way to bridge system engineering world with the manufacturing world deep down to plant level in order to have an end-to-end digital thread?
Same, roughly the same question. So in this case, again, having that MBSE capture the concept and the logical definition of your manufacturing and the value of doing that, right? So just because it's now come up twice, I'm going to throw the value statement in. The value of having that there, so you have a logical definition of what your plants need to be. Then all you need to do is create that physical architecture by selecting the actual equipment that's going into each individual plant for their specific needs. And so that will save you a lot of time because you get reuse of that logical planning phase.
Great. I just saw Rabindra's comment come in on the last one. Perfect. Good job. Thank you. Next question. Do we have more? You got, okay. Misael Gonzalez Santa Maria. Aside from the mentor idea, what are the main references, books, YouTube videos, articles, forums, etc. you can recommend to us?
Yeah, absolutely. So realistically, I'm a big fan in terms of books. I'm a big fan of Lenny Delegati's SysML Distilled as your starting guide, and then reading a practical guide to SysML after, because it's more of the textbook, so it's more in depth. Then I'm a big fan of Mike Vinarsik's videos with this hypermodeling side. So I think it's what is it? Something Guild. I'll have to remember it, but essentially Google Mike Vinarsik and you'll find his videos or something. It's like model-based Guild or something like that. He has a bunch of videos on how to do hypermodeling with it. In addition, I'm a big fan of the Magic Grid Book of Knowledge, which helps you essentially get started in building a model. And then articles and forums. I mean, realistically for those, pay attention to Nkosi and pay attention to the stuff they're publishing for their conferences, because that's going to come at you rapid pace.
You bet. You bet. Good. Do we have more questions? We got one more from Devasish Acharya. How can we address or define variability, uncertainty in MBSE?
So what we do in the defense space is essentially risk, right? So that we quantify into risk, and we have different risk metrics that actually tell us in a mathematical format how much risk we end up having. It's not perfect, but it's good. So, and if you're familiar with STPA, it's based off of STPA. Do not remember what that stands for, but that's kind of the format that we're using. All right. So with that, this past year over the break of Christmas, I had a challenge from our security guys. They're like, hey, our STPA tool sucks. Do you think that you can do it in the MBSE world? And in a couple of days, I gave them a tool that does it in the MBSE model, and they actually said it's better than what they were commercially paying for the other thing. And it was just something that I've built using Magic Draw standard profiles and nothing too fancy. But it's now the best part is security is now integrated into our system architectures. It's no longer an afterthought or a stovepipe. It's right in with the actual definition of the system.
Great. Very good. Nice job. Any more questions? We got one from Ram Walvakar. Your views on leveraging MBSE in Industry 4 scenario where we have model-based definition MBD and model-based enterprise.
No, I love that question right there. So I'm a big fan of just at this point, this day and age, everything really is going model-based, right? A model is that interpretation of a real system, right? So it's a lower fidelity version of the actual thing, but it helps us to actually understand what that is. Every other engineering domain is already there. MBSE is kind of bringing up the back end, and you'll also see even in sales, etc., they're starting to do databases to produce a lot of their standard documentation. So with that, because it's starting to actually become a consistent data artifact, this model-based enterprise is becoming more and more realistic in this day and age. And tools like Syndeia enable you to really interconnect those different disparate tools. So not even just simulation and engineering, but they have tools that do go into like ERPs and whatnot. And because of those centralized capabilities, yeah, we're getting that traceability and that synchronization today. It's at its infancy, but I see that propagating, and that is the future, is starting to use those consistent repositories, if you will.
Nice. Okay, I think we're exhausted at this stage. Let's move on to our great job, by the way. Great job. Well done, Alec. Third section, let's talk about what's next for you. So, Alec, what are your plans over the next year?
All right, so that's the fun part. So I have a baby due at any moment. He's holding on for this brief right here. This is my third, number 3.
Okay.
Yeah, so
you've done the old 2-on-1.
That's right. No more.
Move
No more
on.
after this one.
Okay, great.
But no, we had an agreement, so he's holding on till after this interview. He gave me a high five, so I know it's good. So any second he's coming. And in addition to that, though, so future plans for work stuff. Right now, I'm in the process of essentially doing a lot of research on enterprise architecture or mission engineering, same language, different usage, through to systems architecture, so UAF to SysML to software architecture and UML, and simulation of all those to understand the impact of actual systems and variants in the missions, as well as the impact of the software being deployed on those systems in the impact that has on the mission success as well.
Great, great. What about we got more questions coming in, so we're going to go back to those in a second. But what's the grand plan, future plans for you in MBSE?
Yeah, so my big plan, right, is I'm really, really focused on digital integration. I want to take standard languages like SysML and map those into other standard languages like PSpice or STEP, etc. The reason I want to do that is, first and foremost, I can actually say I'm done one day. So if I try to do every tool API to API mapping, it's an infinite set. You never finish. So at least now I can say, hey, SysML, which is XMI standard compliant to another standard, first of all, any tools that subscribe to that standard, I can take their data and push it over, same translation. Second thing is I can actually say I'm complete at some point in the future, right?
That is big. I mean, the impact on business, if you can do that, is pretty immense. Yeah.
Yeah, that's the big goal, right? Is if you stop having to spend time. So think about it just this way, right? So let's say that I have a 100-pin processor that I'm connecting to a 40-pin GPS unit on a system on a chip, right? And in the MBSE space, I needed to make sure that I line their pins up, ports in SysML, to actually get compatibility on flows. Well, now, today, if I were to just take that image and send it to the electrical engineer, he has to go and build it again in the same format.
Yeah.
If I can, and I've done this, if I can take something like SysML to PSpice and it opens in a PSpice compliant tool, that mapping, that integration is already there. So now he just has to focus on putting in the electrical engineering components like the diodes, capacitors, resistors, whatever, but all those connections are there. And if something's wrong, change it there and it'll propagate back to the actual model to make sure that that's correct.
You bet. So speed and minimized errors, et cetera, et cetera. Nice, nice. Okay, so what are you working on today? What are you working on? I mean, we were talking hypersonic and all that kind of cool stuff. What are you working on?
So for my day job, so when it comes to my client advisory stuff, I'm doing, so I kicked off hypersonics, handed that off. I now focus on NASA urban air mobility, which is one of the pilot programs for MBSE for all of the Aeronautics Research and Mission Directorate for NASA. So there's a lot of things there, like trying to standardize processes for MBSE across the directorate, training, mentorship, you name it. In addition, at MTSI, we stood up one of the first on-demand MBSE training platforms in the market. And so my next couple months is realistically going to be taking that feedback and, refining what we have to get it commercially ready.
Busy man. 24/7, as I said. It must be. Okay.
Coffee and energy drinks.
let's see what other questions we've had come in. I saw a couple more come in there. Great. Back to Misael. Do you think enough recent graduates on the mechanical or mechatronic areas with knowledge on SysML, do you think universities are moving through that path?
So the answer to the first question is no. I don't think there's enough today. I am seeing a lot more universities moving towards that path, so it's encouraging. But the issue that you find in education is a lot of times, or at least in the US, and I don't want to speak for the world, but a lot of times the professors there are, when they're teaching this material, right, they're teaching the standardized textbooks that maybe have changed one chapter in 20 years. So until it becomes the de facto for systems engineering, they may not even have it in their materials. Now you'll
Yeah.
find it in their research labs, but that doesn't cover a large enough percentage of the total graduates.
Yeah, yeah, absolutely. So the reality is there's the education on the streets that needs to be applied as well.
Exactly. And that's, or just realistically, just biting the bullet and coaching it anyways, right?
Yeah.
Doing your senior design projects and that kind of stuff.
Great. Good, good. Okay, next question. How will AI impact MBSE solution software?
Yeah. So in my opinion, again, a lot of the automated functionality, once you can start to define that these are consistent methods across many different groups, you'll start to be able to automate that. So things like production of reports won't be so manual and tedious. It'll be able to be patterns based, which will use AIs to do that. In addition, probably automation of creation of different systems. Like maybe I can say, save template of automobile, and then I tell my tool, go ahead and give me an automobile that has these specs, right? Because I've already have a template, and it will be smart enough to piece that together. That's not stuff that's too far in the future. Verification of requirements. So there's actually a tool that I know Dassault recently acquired that will actually evaluate your requirements against one another, and that's pretty cool because they can handle several 100,000 and tell you where inconsistencies and stuff are there. So that's a major impact as well.
Great, good. I think we are there. I don't think we got any more questions. You have nailed it, Alec. That was really fun. I really appreciate that high level introduction. Well, fairly deep level for some of us. Alec, great. You know what? We are going to do something on a regular basis. We're going to get together in a month's time, and I want to, hopefully get a chance to delve into how you start to build these different models. Let's hopefully do that in a month. So everyone who's joined us today, thanks ever so much for all your questions. And we are going to make sure that we come back in a month and delve even deeper into MBSE. Alec, thanks again.
Thank you, sir.
Appreciate it. Okay, everyone, coming up, we're not going next week. We're going up in about 2 to 3 weeks' time, something around there. We're going to revert back to maybe twice a month, something like that. Some time ago, we talked about the top 4 PLM headaches, and the sparks were flying. It was like the presidential debate. We had a lot of fun. We hit a lot of the main areas. It was popular. It got a lot of engagement from you and a lot of questions. Next time, we're going to pull in a PLM, an MES, and an ERP expert and let the sparks fly. Do we need them all? Do we need some of them, or don't we need any of them? I don't know. Let's have a look at it together and see those opinions come together. Thanks for joining us. I appreciate you taking the time out, and we will let you know in about 2 to 3 to 4 weeks' time the next big show, PLM, MES, ERP. Who needs it? What do we need? See you then. Have a great time ahead.